Hello, and welcome to 5 Minutes about Apache Pulsar. My name is George Trujillo, and I'm on the streaming team at DataStax. Today, I'm going to give an overview of geo-replication with Apache Pulsar and sharing key business outcomes, the relationship between architecture and replication, as well as common replication patterns. Before we get started, if you don't already have a deployment of Pulsar, visit the URL below and get a free Pulsar instance up and running in under a minute. If you have any questions or feedback, you can leave a comment or email us at pulsarquestions@datastax.com, and that will go to the Pulsar team here at DataStax. Business outcomes should be part of the selection process for any messaging replication strategy. Here are 4 key benefits to consider with Apache Pulsar. Faster deployments. Pulsar makes it easy to align messaging replication with application and database strategy. This is important because applications often feed data streams and data streams feed databases. Reduce costs. Geo-replication is built into open source Apache Pulsar. This helps unit costs as your data streams grow or expand from on-premise to hybrid cloud or multi-cloud. Minimize complexity. With geo-replication being a straightforward configuration, technical complexity is minimized as the environment evolves. Cloud native. With Apache Pulsar being a first-class data citizen with Kubernetes, it is very easy to align applications with data streams leveraging cloud-native capabilities such as containers, unit testing, continuous delivery, and reliable deployments. Most important, this reduces data barriers for application development teams. 2 of the many strengths of Apache Pulsar include its horizontal distributed architecture and its enterprise-grade geo-replication. Here, we see Pulsar's distributed architecture, separating compute and storage, highlighted here with broker and bookie server processes. In the next few slides, you'll see the distributed architecture's role in how synchronous and asynchronous replication works. With synchronous geo-replication, an application will wait for acknowledgement that a minimum quorum of writes has succeeded across the Pulsar clusters. Synchronous replication has higher latency because the application has to wait for acknowledgement from the other Pulsar clusters. Since synchronization is based on multiple writes succeeding, bookie processes are responsible for synchronous writes. Synchronous replication has high availability and stronger data consistency, but latency is impacted due to acknowledgement across Pulsar clusters succeed. With asynchronous geo-replication, an application will send a message to a Pulsar cluster. The brokers will then replicate the data between the clusters. Asynchronous replication is lower latency because when the replication is done, Pulsar creates producers on a background thread and follows the same acknowledgement quorum and persistence that the originating producer did. This ensures that logging and notifications are not bubbled up. Pulsar still guarantees replication to the other clusters. Data consistency is dependent upon the latency across the Pulsar clusters. We're now going to look at 4 replication patterns to highlight different ways synchronous or asynchronous replication can be configured, dependent upon business requirements. First, let's look at mesh. A client application will work with the closest Pulsar cluster. A consistent global state is maintained across the Pulsar clusters within a time window. Here, active-active replication is an example of mesh using synchronous replication with 2 data centers. Active standby. One Pulsar cluster is active for users with the clusters being synchronized. If the active Pulsar cluster becomes unavailable, failover will make the standby cluster active. Granularity. Pulsar supports replication for all topics in a namespace or for individual topics. This can be defined at the namespace or at the topic level. An administrator can define which regions are part of a namespace. A producer application can also define which messages are defined to go to a specific region. Aggregation. Individual Pulsar clusters can send data to be replicated to a centralized Pulsar cluster. Thank you for watching this quick overview of geo-replication in Apache Pulsar.